In this video, I'm going to walk through the process of writing an R package with lidr. We'll start by going to the lidr website, and under Getting Started, we can copy to the clipboard this command, which will create a R Markdown file for us from template. And the template we're using here is called, as you can see here, called Make an R Package. That's the simplest of the templates. There are a bunch of templates, and if you want to see all of them, you can go under Articles to the R Package templates and choose among different templates. Like there's one, for example, for R packages that involve RCPP. Okay, but for now, we're just using the most basic one. And this is going to create a file given by, well, right now it would be create rhello.rmd. In this example, we're going to create an R package that does least squares. So I'll call that package R least squares. So when I press enter, this is going to create this new file right here. And so let's open it, create R least squares. Okay, scroll just to the top. Okay, so first of all, we want to change the name of the package to R least squares. Okay, and you might put your name here, the date if you like, and then we go to the next part, which is defining all the kind of metadata about the package. So let's give it a title, a package that, well, does least squares. Okay. And then we can describe the file in a little more detail. So this package fits a least squares estimator to the data. Okay. And then you might change your name if you like. And okay, and so now to the package itself. I'm going to just delete actually what's in this template. I'll just leave this bottom part has a call to litr document. And this is going to be, you'll want to leave that there because that's going to basically make sure that all the documentation pages are created as we'd want them to. Okay, so now let's get to the meat of the package. So I can change this, so let's call it fitting least squares. Okay, so let's describe, the nice thing about the Literate programming framework is we actually describe what we're doing and we have that description right there together with the code. So in this case, we'll say, okay, suppose we have a response vector y that's in Rn, and design matrix x that's in Rn by p, right? And so we can use latex as we're doing here. So what is least squares? So least squares, okay, let's say the least squares estimator is the solution to the problem. We can write it out. Okay. So it is solving that problem. Okay. The solution is given by, and well, we can use this closed form solution for it. Okay, we have an inverse, so maybe let's just add where we assume that x is full rank with n greater than p. Okay, it's given by that. So now we're ready to write some code. And the nice thing is we have the latex right here, so we can refer to it as we write this function. So notice I'm using the roxygen, which is the nicest way to be documenting functions that are in R package anyway, but it's particularly important with lidr because this is what signals to lidr that what we're about to write will be a function that should be included in the R package. So fit a least squares. Let's just say fit least squares. Okay, and so we'll define what the arguments are. So this function should take x and y. So x is a n by p design matrix, and y is this is an n vector. Okay, a response vector of dimension n. And then we can describe what this function, we're basically writing exactly what somebody's going to see whenever they do question mark name of our function. So this function fits at least squares model to the data. And so I'm going to add @export. What this does is this makes it so that the function will actually be visible to a user when they load the package. We name our function, let's call it fit least squared, fit ls. And so again, it takes x and y. I guess maybe let's include the option to have an intercept or not. So intercept, and let's make the default be true. Okay, so inter equals true. We might start with like some check, like make sure that the number of rows of x matches the length of y. I'm not going to add a check right now that it's a full rank matrix X, but maybe at least in the documentation, let's add that. It assumes that X is full rank. So we have this inter. So if it's true, we'll want to add a column of ones. So if inter, then let's make X be the matrix X, but with some ones added to it. And then finally, we want to implement this equation we have here. So first of all, we'll use the function solve for this inverse. And to form X transpose X, there's this function cross prod in R. So cross prod of X, that is X transpose X. Solve, that's giving us that inverse. And then we'll multiply it by another called a cross prod of X comma Y. So that looks pretty good. So maybe I'll say, in the spirit of literate programming, maybe I'll explain a little bit about this intercept. So we'll make our function optionally include an intercept. To include an intercept, we would use the above formula, but with X redefined to be X, okay, where this 1 sub n is a vector of all ones. Okay, so that's good. At this point, we could press knit and have a look at what we've been creating. So here, creating the least squares package. We have the description stuff that we included, and now we have this main part. So fitting least squares, and this looks good. The latex rendered nicely, and we see the code right after the explanation. So that's good. Now remember, with lidar, whenever we press knit, it doesn't just create that HTML file. It also creates an R package. And so let's have a look at the R package now. So R least squares, here it is. We have our description file with all the information about, it's been updated, all the information about least squares. We have our R folder that has the code, and yeah, sure enough, this is it. And then what else? We have a man page that has the documentation for our function. That comes from the R oxygen, this first bit that we wrote here. And then finally, we have the namespace file, and this specifies which functions get exported. In other words, which functions will be visible to a user versus kept to be internal. So it was the fact that we had this @export here that led to the namespace file having this line. Okay, so great. So at this point, this is a fully functional R package, and so we could actually install it, install if we want, but I'm just going to keep going in this R markdown file for now. We've written a function. We really want to, the next natural thing to want to do is to actually try it out. So let's try this out on an example. Okay, so I'm going to generate some data. Setting a seed is always a good idea. So let's imagine we have 100 points, and and I'm just going to take one dimension data for now, and let's generate some standard normal data for the entries. And yeah, so this is actually truly just n by 1 matrix at this point. And okay, now I'm gonna have some true beta. Let's say it has intercept 1 and slope 2 maybe. And now let's generate y based on that. So it'd be x times beta true plus, let's add some noise. So we'll do, I don't know, maybe 0.2 standard deviation noise. Okay, so let's, by the way, we can run this just like in any other, our markdown file. And so let's look at the data. Actually, let's fit. So I'm going to call fit ls, the function we just defined, with this x and y. And let's call that beta hat. Okay. And so let's run all of this. Oh, okay. Well, I just got an error. It says fit ls n row of x does not equal length of y. Okay, well, let's see. What is the dimension of x? 100 by 1. What is the length of y? Ah, it's 200. How did that happen? Well, somehow when I did x times beta true, let's see what the dimension of that was. 100 by 2. Ah, oh yes, I see the problem. The problem is what I wanted to have here is because of the intercept. I actually wanted to have this be a 100 by 2 matrix. Okay, great. So if I run that now let's have a look. Okay, that looks good. Beta hat is actually, it's a matrix. I'd rather it just be a vector. So what I'm going to do is I'm going to add as.numeric here. Okay, let's rerun this. And now when we run this, let's look at what beta hat is. Okay, good. So that looks nice. Now remember the true beta true, we had it be 1, 0, right? Or sorry, 1, 2. So we see that it's actually quite close, right? We have 0.97 and 1.98, so quite close. That's good. Okay, so let's look at the data and the fit. And so I'm going to just make a plot, scatter plot of the data. And now I'm going to add my beta hat that I got. So that's the intercept and then the slope. And let's see what we get if we run both of these together. Great. Okay, that looks good. That looks like a line going right through the data as we'd expect for least squares with 100 points. Good. All right, so what next? Well, we might want to verify that actually we are solving the problem correctly, and we could do that by saying, let's check if this matches one of the functions that exists in R already, for example, lm. Okay, so let's check if this matches what lm would give. Okay. So lm, right, we would do y tilde x, and I'm just going to extract the coefficients from this. And so let's call this beta lm. Run that, and we can have a look. Okay, and so this is actually a good point, which is, when you're coding, you're probably doing checks like this, and you might actually now want to say, okay, what if we take beta hat minus beta lm? And we see, oh yeah, okay, this is very close, right? These are within 10 to the negative 15 or so of each other. So that's good. So when we're coding, we do these checks anyway. But really what we want to do is have these checks built into our package so that they're there, into the future. If somebody makes a change to our package later, we want to be able to make sure that they're not going to break any of the functionality that we had checked earlier. So we can do that by writing a test. So, I mean, one idea is you could just make a test in this document, right? So we could say, let's see how they compare, right? And so we could do something like this. We could even take the range or something and say, okay, we could say, good, they're basically identical. But again, this doesn't really live with the R package. We'd really like it to be in the R package, and that's the value of making a unit test. So let's turn this into a test that will live in the package. And for that, we'll use the R package testthat. Okay, so testthat, we're going to give this test a name. We can write a bunch of tests. So let's test that that our function, so fit ls matches lm. Okay, so and now we're going to define that. So we've actually written the code already, right? So let's scroll up, and so I can copy all of this code where I'm defining the right, generating the data and then fitting. So so fit using fit ls, and then now fit using lm. So let's go copy this here, and then now compare. All right, and so testthat has a function called expect equal, and we can put in beta hat and beta lm and check that they're the same. So let me just try running this right now. Aha, so I ran this test and it says failure. Fit ls matches lm, so that's the name of the test. And it says, oh, actually they're not equal. Okay, so why are they not equal? Let me just try running all this and having a look. So what would not be equal about this? We saw that in number they're about the same, right? So one thing we see is that actually beta lm has some names associated with it. So let's actually add an as.numeric around here. And now let's see if that fixes it. Yeah, okay, great. The test passed now. Okay, we can try knitting the package, or knitting this file, which both will update the HTML file so we can all look at it and see the figure. That's nice, and everything, all the explanation, and we see the test pass. But furthermore, now the R package has also been updated. Whenever we press knit, that happens. And notice there's a test folder here now. And if I go into testthat, there's test.r, and my test exists right there. Okay, so that's great. So we can now we can do dev tools. We can install the package, which means we have to find where it lives, which is just this folder called rleasquares. Run that, and that was successful. We can have a look by calling our function on some x and y. That's good. I can just test it. Let me try like 1 to 10, 1 to 10. That should give something that's basically intercept 0 and slope 1. Okay, that's good. I can have a look at the, let me just look at the documentation for this. Question mark, name of function. There it is. Looks good. And then and you know, I can also do dev tools besides installing. I could do test, and when I do this test function, it runs through all the tests that I've defined in the package. And so here it is, and this tells me, so okay, there's a warning because apparently the version something about the version of R I'm using, but the good thing to see here is actually no tests failed, 0 tests failed, and 1 test passed, so that's good. I can also do DevTools check. This is especially useful if you're going to post your package on CRAN. It runs a bunch of detailed checks about the R package, including running all the tests that were there. And that's great. We have no errors, no warnings, no notes. So this package will be ready to go.